Imagine Earth as a 24-hour clock. The planet forms just after midnight. Life appears early in the morning. Dinosaurs dominate for most of the day. They disappear shortly before 11 p.m. And humans show up in the last few seconds before midnight. That alone should make us pause. Because if humanity arrives so late, how do we even decide when the clock should start ticking for us? Is it when the first creature walked upright? When stone tools appeared? When language emerged? Or only when Homo sapiens looked enough like us that we'd recognize them as human? This is where things get interesting. Humans weren't created in a single moment. We didn't pop into existence fully formed. We emerged slowly through countless tiny changes across deep time. Like a color gradient fading from blue to green, there's no sharp line where you can point and say, this is the first human. And yet we still want an answer. So to find one, we'll have to do something unusual. We'll have to travel through myths, calendars, fossils, and DNA. We'll compare stories told by ancient civilizations with evidence locked inside rocks and bones. And along the way, we'll discover that the question, how long has humanity existed, depends entirely on what you mean by human. Long before fossils and DNA, humans already had answers. They didn't come from measurements or experiments. They came from stories, from kings' lists carved into stone, from sacred texts, from myths meant to explain not just when we began, but why. And almost everywhere we look, those answers point surprisingly close to home. In ancient Mesopotamia, the Sumerians recorded lists of kings who ruled before a great flood, not for decades or centuries, but for hundreds of thousands of years. 8 kings, enormous reigns. Time itself stretched to mythic proportions. A few centuries later, the Babylonian priest Berossus refined the story. According to him, humanity's pre-flood history lasted exactly 432,000 years. Not an estimate, a precise, meaningful number. In Egypt, time took a different shape. Herodotus wrote that Egyptian priests showed him records of over 300 generations of pharaohs, reaching back more than 11,000 years. To them, civilization didn't begin suddenly. It unfolded through an almost endless lineage of rulers. The Maya carved time into stone. Their calendar famously begins in 3114 BC, marking not the creation of humans, but the reset of a cosmic cycle. Humanity wasn't new. Time itself was simply starting over again. China traced its origins to legendary emperors. The Yellow Emperor's reign begins around 2697 BC, placing the start of Chinese civilization within a semi-mythical, semi-historical past. And then there are the Abrahamic traditions. Judaism places the creation of humanity around 3761 BC. Christianity produced several calculations, with the most famous by Archbishop James Ussher, dating creation to October 23, 4004 BC. Islam generally avoids exact dates, but often places humanity within a world only a few thousand years old. Different cultures, different stories, different numbers. But notice something important. Almost all of them keep humanity close to recorded history. Not millions of years back, not deep time, just far enough to explain the world as it was known. And that makes sense. Writing itself only appears around 3400 BC. Before that, history survives through memory, through stories passed from mouth to mouth, slowly changing, simplifying, compressing vast stretches of time into something a human mind can hold. These stories weren't trying to be scientific. They were trying to be meaningful. But meaning has limits, because as soon as humans began to dig into the ground instead of into myths, they found something unexpected, a past far older than any story had imagined. Stories can stretch time. Science compresses it. Instead of asking ancestors what they remembered, science asked the planet itself. And it turns out Earth keeps excellent records, not in words, but in layers of rock, in radioactive atoms slowly falling apart, in tiny magnetic signatures frozen into stone. This is where deep time begins. By measuring how fast certain atoms decay, scientists discovered something unsettling. Earth isn't thousands of years old. It's about 4.54 billion years old. The universe itself is older still, around 13.8 billion years. Suddenly, all human history became a rounding error. Writing appears at the very end of the timeline. Agriculture shows up seconds before midnight. Everything we call civilization fits into a blink. But even that wasn't the biggest surprise. When scientists started finding fossils of human-like creatures buried deep beneath the surface, they didn't belong to us. Not quite. They walked upright. They used tools. Some had large brains. But they weren't Homo sapiens. They were something else. Radiometric dating placed these fossils hundreds of thousands, then millions of years old. And the deeper researchers dug, the more crowded our family tree became. There was no first human, no clean starting point. Instead, there was a slow, branching process. Generation after generation, small changes accumulated. Slightly different teeth, a pelvis shaped a little better for walking, a skull that could hold a slightly larger brain. Each individual was almost identical to their parents. But over vast stretches of time, those tiny differences added up. This created a problem. If humans evolved gradually, then where exactly do we draw the line? When does an ancestor stop being not human and start being us? Science doesn't like vague answers. But here, vagueness is unavoidable. So instead of asking when the first human appeared, scientists changed the question. They asked how humans are related to everything else. And to do that, they built a system to organize life itself. To understand how long humanity has existed, scientists stopped asking who came first and started asking who is related to whom. That's where taxonomy comes in. Taxonomy is basically a giant family tree for life on Earth. Instead of surnames, it uses shared traits and common ancestors. And when you place humans on this tree, something becomes very clear very quickly. We are not alone on our branch. At the broadest level, humans belong to the great apes. That group includes chimpanzees, gorillas, orangutans, and a few smaller cousins. If you go back about 23 million years, you'd find a creature that eventually gave rise to all of us. From there, the branches slowly split. Around 17 million years ago, one branch leads toward what we now call the human family, leaving gibbons behind. A few million years later, orangutans take their own path. Then gorillas, then chimpanzees. Each split feels clean on a diagram. In reality, it was anything but. Populations drifted apart. Some mixed again. Traits changed unevenly. Evolution didn't care about tidy categories. It just worked with what was available. By about 7 million years ago, the lineage that would eventually become human was distinct from chimpanzees. But distinct doesn't mean modern. These early hominins still had small brains. Many could climb trees. Some walked upright only part of the time. They weren't almost human. They were exactly what evolution needed them to be. Then around 6 million years ago, the human line narrows further. Scientists call this group hominins. This includes us and a surprisingly large number of extinct relatives. At least 30, probably more. Some were short, some were tall, some had powerful jaws, others had delicate faces. A few used tools. One or two might have buried their dead, and none of them knew they were part of a category called human. This is why defining the start of humanity is so difficult. No single species suddenly appeared and replaced the others. Different hominins overlapped in time. Some interbred, some vanished, some left descendants who are still alive today. Which brings us to a crucial question. If humanity didn't begin with us, then when did our own species finally arrive? To answer that, we have to zoom in further, down to a single genus, a name that literally means human. About 2.8 million years ago, something subtle but important happened. A group of hominins began to change in ways that set them apart from all the others. Their brains grew a little larger. Their hands became better at precision. They started shaping stones on purpose, not just using whatever they found. This is when scientists introduce a new label, Homo. The word simply means human, but in taxonomy it marks a shift, not a sudden leap, not a miracle, just a pattern that kept repeating and intensifying over time. The earliest known member of this group may be Homo habilis, the handy human. Their stone tools were simple, but intentional. Sharp edges where there hadn't been any before. A small change with huge consequences. After that, the genus didn't move in a straight line. Homo erectus appeared and spread far beyond Africa. They walked fully upright. They had bodies built for long-distance travel. They likely controlled fire. For nearly 2 million years, they were the most successful humans on Earth. And they weren't alone. Different Homo species existed at the same time. Some were robust, some were gracile, some stayed local, others traveled across continents. Evolution experimented freely. This wasn't a ladder, it was a bush. Branches split. Some ended quickly. Others lasted hundreds of thousands of years. Occasionally, branches crossed again. We now know that different human species didn't just replace each other. They sometimes met, and sometimes they had children, which leads to an uncomfortable realization. For most of human history, we were not the only humans. Neanderthals lived in Europe and Western Asia. Denisovans ranged across parts of Asia. Other Homo species existed in places we're still discovering. Each one adapted to their environment in slightly different ways. They hunted. They cared for their injured. Some made art. Some buried their dead. They were human, just not us. So where do we fit into this crowded picture? At some point, one branch of the Homo bush became something new. Not smarter in every way, not stronger, but different enough that eventually only they remain. Around 300,000 years ago in Africa, a population of humans appeared that looked familiar. Not modern in the way we'd recognize on the street, but close enough that the differences start to feel cosmetic rather than fundamental. Smaller faces, lighter jaws, skulls shaped to house a highly flexible brain. These were Homo sapiens. For a long time, scientists assumed our species was younger, maybe 200,000 years old. Then fossils from places like Jebel Irhoud in Morocco pushed the date back, further than expected, deeper into time. And just like everything else in human evolution, this wasn't a clean beginning. Early Homo sapiens didn't instantly replace everyone else. For most of our existence, we shared the planet with other humans. We overlapped, we interacted, we interbred. Right now, if you look inside your own DNA, you'll find traces of that. Many people carry Neanderthal genes. Some carry Denisovan genes. These aren't metaphors. They're measurable, which means our story isn't one of simple domination. It's a story of mixing, merging, and surviving. So why did Homo sapiens outlast all the others? It probably wasn't raw intelligence. Neanderthals had large brains. It wasn't strength. It wasn't even tools. Others had those too. What seems to matter is flexibility. We formed larger social networks. We shared information over long distances. Ideas spread faster than genes. Cultural evolution began to move quicker than biological evolution ever could. Language, symbols, shared myths. These let small groups behave like something much larger. By around 70,000 years ago, Homo sapiens began spreading across the globe. Australia, Europe, Asia, eventually the Americas. Everywhere we went, other human species disappeared, sometimes slowly, sometimes abruptly. By about 40,000 years ago, we were alone, the last humans standing. But this raises a final, uncomfortable question. If our species is only 300,000 years old, and everything before that was still human in some sense, then what does it really mean to ask how long humanity has existed? To answer that, we need to zoom out one last time. At this point, the question starts to break apart. If by human we mean Homo sapiens, then the answer is fairly clear. About 300,000 years. That's when fossils, genetics, and geology all line up. But if we mean something broader, the answer stretches. If humans are tool makers, then humanity begins over 2.8 million years ago with the first members of the genus Homo. If humans are upright walkers with small brains and flexible behavior, then we go back 6 million years to the earliest hominins. And if humans are simply one branch of the great apes, then our story merges with chimpanzees, gorillas, and orangutans more than 20 million years in the past. There is no single moment where nature rang a bell and said, humanity starts now. Every generation blended into the next. Parents and children were always the same species. The line only becomes visible when we zoom out far enough. This is why debates about the first human never end. People are arguing about definitions, not facts. Evolution doesn't create categories. We do. And once you see that, the timelines stop competing with each other. They answer different versions of the same question. Religion asks when humans were given meaning. History asks when humans left records. Biology asks when populations diverge. Genetics asks when lineages split. All of them are valid within their own frame. But science has one advantage. It lets us test its answers against the physical world. Fossils can be dated. DNA can be compared. Rocks don't change their story to fit ours. Which brings us to one final thought. If humanity emerged gradually and evolution never stops, then the story isn't finished. Not even close.